My name is Marta Cañamero. I come from Madrid, Spain, and I'm working in the National Cancer Institute, the CNIO. I'm running the immunohistochemistry lab. Well, it's the comparative pathology lab, because we try to validate all the mouse model for human diseases. There are some programs that are trying to reprogram cells, iPS cells, and also people who is trying to find stem cells in different localizations and cancer stem cells. We mostly work with paraffin sections, and we are using a lot of antibodies that is quite difficult to find good antibodies that work on mouse paraffin sections. It's easier if you are talking about of human samples, but we are mostly working with necropsies from different transgenic mouse lines or stem cells. Yes, that's why I'm interested in this meeting, because here you can hear what is people working in different fields, in different kind of antibodies that are marking different stem cells or more compromised cells in different compartments. So some people is talking about mammary gland and or about skin. So for me it's good because I have a lot of good ideas.
My name is Yvonne Reed, and I am the collection scientist at ATCC, and we're now located in Manassas, Virginia. So my purpose here was to actually give a presentation that focused primarily on authentication of cell line and ways to reduce cross-contamination of cell lines. Since development of human stem cells is a very fast and growing field, we thought that the information that has been learned from past experiences could also be applied to human stem cells. The single most important technology right now, especially for human identification, is STR analysis, where we're looking at short-tandem repeats, and these are very polymorphic markers that can be used to uniquely identify each human cell line. These are the same markers that are being used in forensic and is now applied to cell biology or to human cell lines. I thought this conference was very, very interesting. I haven't been to one of these in most recent time. I've been to some of the early ones, and I'm very, very impressed in some of the advances that has taken place, especially in the era of direct differentiation and the new reagents that are being used to carry out differentiation and the different markers that are associated with that. So I'm actually quite impressed. Yeah.
I'm Joseph Yanai, and I'm from the laboratory for the reversal of neural birth defects at the Hebrew University Hadassah Medical School in Jerusalem. Basically, we are trying to reverse neural birth defects, and we try to do it with stem cells of different type. Normally, we are taking stem cells from a day-old newborn mouse. But now we are trying to get into or to approach more clinical application, and we are using bone marrow stem cells, nasal mucosa stem cells, and another avenue that we are taking is transplanting these cells in least invasive way, which is through the blood vessels. Apparently the brain, and that's what we believe based on data, that the brain that is damaged is calling for help and making sure that some of the cells will go to the brain. Others will go whenever they go, and as long as they don't make tumors, we don't care what they're doing. It's an exciting conference. The growth of the association and the people who work on stem cells is incredible. To my taste, I wish that the next meetings will focus more on application.
So I'm Sébastien Duprat. I'm coming from France, but I'm working in the UK right now. So I'm working for a European consortium. So the EU is funding large cross-country projects that allow scientists, of course, to work together and build a critical mass in order to define the standards in the field. So my role there is to take care of the training. So of course, identify excellence when I'm visiting an institute to make sure that they either what they need, but also what they can deliver to other institutes. But also I take care of the networking and education to the large public. And of course that is done in 10 different countries with different cultures, languages, religions, backgrounds, and it needs to be using some material that is developed specifically to be cross-cultural and cross-educational.